Of course, what we are leading up to here is to solve the polynomial completely. And so on these, they're going to give us a factor, and then we're just going to keep going from there. So here we have a very long, complex polynomial. It is to the 5th degree. We can't factor this. We don't know how. There's no way to do it. So they were very nice to us, and they did give us that this is one of the solutions. So what I need to do is to see what's left over once I've divided it by x minus 6. Now what I could do is do long division, but that makes me want to cry a little bit because this is a very, very long question. So instead, because this is a 1 x to the 6th, I'm going to use the opposite of minus 6, so positive 6, and I'm going to use synthetic division because it's faster. So 4x to the 5th minus 24x to the 4th minus 3x to the 3rd, 18x to the 2nd, negative 1x to the 1st, and 6. I'm going to bring down my 4. I'm going to multiply and add, multiply and add, multiply and add, multiply and add, multiply and add. Now, if I would have gotten anything other than a 0 here, I know I did something wrong because it already told me that this is a factor. Now, why did I have to do that step? Because I needed to see what I have left over. So this is 4x to the 4th minus 3, so there was a 0x to the 3rd, so minus 3x squared, and this is a minus 1. So this is what's left over once I've divided it by x minus 6. So my factorization so far is x minus 6. So I'm going to write it so I don't forget. Now I have this, and this has 3 terms, and I know when I have 3 terms and they're both even, so 4 and 2, I can maybe use that quadratic model that we've talked about before. So I would say, are there numbers that multiply to AC, which is 4 times negative 1? So multiply to negative 4 that add to negative 3. So numbers that multiply to negative 4 that add to negative 3 would be negative 4 and 1. Now where did I get that negative 4? I took 4 times negative 1. That was the AC method. Multiply those two, and then they have to add or subtract to this middle value. In this case, they have to subtract to that. So that means I can write this as, and this is sort of that u substitution thing. So if u is x squared, this is 4u squared minus 3u minus 1. Using the method that we've talked about before, I'm going to write this as 4u squared minus 4u plus 1u minus 1. Now why did I do that? Because these two values are the same as minus 3. Negative 4 plus 1, that's still minus 3. And this I can factor by grouping. So I'm going to call this 4u, u minus 1. And these two I would take out a 1, which would leave me with u minus 1, which gives me 4u plus 1, u minus 1. I already said that u is the same as x squared, so I'm going to pop that x squared back in there. If you don't know what I'm doing here, make sure you go back to that lesson on factoring in a quadratic form. This is x squared minus 1. So this one will factor more because this is a perfect square minus a perfect square. This one will not. So 4x squared plus 1 is as far as that factor will go. This will turn into x plus 1, x minus 1. So my factorization would include the x plus 1, the x minus 1, and then this whole thing because it won't go any further. Finding the zeros would be what happens when I take x minus 6 and set it equal to 0. So my zeros would be positive 6, negative 1, positive 1, and then I would have to set this one equal to 0, which gives me 4x squared equals negative 1, x squared equals negative 1/4. I would take the square root, so x equals plus or minus 1/2 I. So my other two solutions would be 1/2 I and negative 1/2 I. So notice there's 5 solutions, 1, 2, 3, 4, 5. I've got them all. 2 of them are imaginary, but that's okay. I should have 5 total solutions. That's kind of a long question, but go ahead and try this question also. Press pause, do the entire process just as we just did, and then press play to check your work. Again, this one tells me that a 0 is -4, which means x minus -4 is a factor, which of course just means it's x plus 4. So x plus 4 is a factor. So down here I'm going to write my factorization and my zeros. So far I know that my factorization includes x plus 4, and one of my zeros is -4. So let's go ahead and plug -4 in. This is 2x cubed, 7x squared, minus 14x to the first, minus 40. Don't forget you'd have to use zeros as placeholders if you needed to. Bring down the 2, multiply, add, multiply, add, multiply, add. I should get a remainder of 0 because they already told me it was a factor. That leaves me with 2x squared, again 1 less than that, minus 1x minus 10, it's still equal to 0. From here I would try to factor this. I would say, are there numbers that multiply to -20 that have a sum of -1 or have a difference of -1? So numbers that multiply to 20, you can always make your little list, your little table. Multiply to 20 would be 1 and 20, 2 and 10, 4 and 5. Do any of those have a difference of 1? They sure do. Again, where did I get 20? I took 2 times -10. Now I need it to be a -1, so I would do a -5 and a +4. So 2x squared plus 4x minus 5x minus 10 equals 0. And now I'm going to try factoring by grouping. Remember, from here you could also tic-tac-toe. So if you're a tic-tac-toe fan, go at it from right here on this step. That gives me 2x and then x plus 2. That gives me -5 and then x plus 2. So this is working out pretty well. I get 2x minus 5, x plus 2, which means that's the rest of my factorization. Doesn't matter the order that I write it in. My zeros would be when I set this equal to 0, which gave me the -4, when I set this equal to 0, which is 5/2, when I set this equal to 0, which is -2. How many zeros could I have total? Just 3. So in this case, they were all real zeros.